Hello, in this lecture we find out the ratio between two radii. In the drawing we have a big circle. Inside this big circle we have two small circles, and the radius of the smallest circle is equal to A, the radius of the bigger circle is equal to B, and our mission is to find out the ratio between the two radii, that is to say the ratio B over A. And inside the biggest circle we have a right triangle ABC that is partially located inside the biggest circle. The length of side AB is equal to 5 units, side BC equals to 12 units, and the right triangle and this angle ABC equals to 90 degrees, and the right triangle ABC blocks the circle. Okay, so our mission is to find out the ratio of B over A. So first of all, we implement the Pythagoras theorem on the right triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle ABC is AC, therefore the square of the hypotenuse is AC square, and it must be equal to AB square plus BC square. Repeat again. Right triangle ABC, according to the Pythagoras theorem, AC square equals to AB square plus BC square. So AC square equals to AB square. AB is 5, therefore AB square is 5 squared, that is 25, plus BC square. BC is 12, therefore BC square is 12 squared, that is 144. So AC square in total equals to 25 plus 144 is 169. You take out of this equation, you get that AC equals to the square root of 169, that is 13. Actually, it is given in the question that AN is equals to NC. So the hypotenuse AC equals to 13 units in its length. At point N, the hypotenuse AC is bisected into two halves. The first half is AN, the second half is NC. So actually, it means that AC over 2, that is 13 over 2, will be equal to the first half, that is AN. It will be also equal to the second half, that is NC. Okay, so AC over 2 equals to 13 over 2, that is equal to AN, that is equal to NC. So we can find out that AN equals to NC, and each half equals to 13 over 2. Here, the second half NC equals to 13 over 2 units in its length. I'll write it down. In the next step, I present to you a new rule and to implement the new rule in our drawing. According to rule number 8, the radius of a circle that is blocked by a right triangle is equal to R equals to A plus B minus C over 2. So we have the right triangle ABC. The right triangle ABC, this angle equals to 90 degrees, angle ABC. And this right triangle ABC blocks this circle. According to rule number 8, we can find out the radius of the circle that is blocked by a right triangle only by knowing the side lengths of the right triangle. That is to say, here we know that side AB of the right triangle ABC equals to unit sinus length, side BC equals to B unit sinus length, and the hypotenuse AC equals to C unit sinus length. Then the radius of this circle that is blocked by the right triangle ABC will be equal to A plus B minus C over 2. Again, the radius of this circle that is blocked by the triangle ABC equals to A plus B minus C over 2. So we can implement rule number 8 in our drawing. Why? Because in our drawing we have the right triangle ABC blocks this circle. The radius of this circle is A. So according to rule number 8, the radius A will be equal to AB plus BC minus AC over 2. So I write it down. The radius of the small circle will be equal to AB plus BC minus the hypotenuse AC over 2. This is according to rule number 8. It's given us the question that AB is 5 plus BC that is 12, and you just right now found out that the hypotenuse AC equals to 13 over 2. So in total, again, AB equals to 5, BC equals to 12, and the hypotenuse AC equals to 13. So it is 5 plus 13, 5 plus 12, that is 17, times 13 over 2. 17 times 13 is 4, and 4 over 2 is 2. So I found out that the radius A of the smallest circle, A equals to 2 units in its length. So I figure that radius A equals to 2 units. We define the center of the smaller circle of this circle as P. We define the center of the bigger circle as Q. And we define the center of the biggest circle as O. This is the biggest circle. We define the point of tendency of tangent AB with this circle as T. Then we join points P and T together by a straight line. Again, point T is the point of tendency of tangent AB with this circle. Again, point P is the center of the smallest circle, point T is the point of the circle itself, therefore PT is the radius of the circle that is equal to 2. The radius PT is drawn to point T, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, according to rule number 1, tangent AB will be perpendicular to the radius TP. If AB is perpendicular to TP, it means that this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, we define the point of tendency of tangent BC with this circle as N, and then we join points P and N together by a straight line. Pn is the radius of this circle that is equal to 2. The radius Pn is drawn to point N, that is the point of tendency of tangent BC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius NP. If BC is perpendicular to NP, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. So actually, in quadrangle PTBN, we have 2 free right angles. The sum of free right angles is 90 times 3 is 270 degrees, plus the missing angle. In total, those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. Again, in order to complete the sum of the angles in quadrangle TPBN for 360 degrees, the missing angle here must be equal to 90 degrees. So actually, in quadrangle TPBN, we have 4 right angles. Any quadrangle that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrangle TPBN as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, Pn equals to Tb. But Pn is 2, therefore Tb must be also equal to 2. Likewise, in quadrangle TPBN, side Tp must be equal to the opposite side Bn. But Tp equals to 2, therefore Bn must be also equal to 2. So actually we found out that quadrangle TPBN is not a square, but it's not a rectangle, but a square. Why? Because all of its sides are equal to each other, they are equal to 2 units. So here, we know it is given us in the question that PA equals to 5. So BA minus BT, again BA minus BT equals to TA. PA is 5, BT is 2, 5 minus 2 is 3. So AT is 3, T equals to 3 units in its length. Here we have rule number 2 that states that the lengths of 2 tangents from a common external point to a circle are equal. We have the common external point, point A. From the common external point, point A, we have 2 tangents to this circle, tangent AT and tangent AM. And according to rule number 2, they are equal to each other. That is to say, AT equals to AM, but AT is 3, therefore AM must be also equal to 3. We already found out that AN equals to 14 over 2. AM equals to 3, so AN minus AM equals to MN. Again, AN minus AM equals to MN. I'll write it down. AN minus AM equals to MN. AN is 13 over 2, AM is 3. Here we multiply 3 by 2, and then we divide it by 2 in order to overcome a factor with 13 over 2, and we get that 13 over 2 minus 3 times 2 is minus 6. 13 minus 6 is 7 over 2. So we found out that Mn equals to 7 over 2 units. The length of line segment Mn is 7 over 2. So I can write down in the original drawing that this line segment Mn is equals to 7 over 2. Okay. So in the next step I present to you a new rule, and we'll implement the new rule in our drawing. Here is rule number 8. According to rule number 8, if two circles touch each other internally, then the straight line that connects their centers together passes through their touching point. So here point O is the center of the big circle and point M is the center of the small circle. The straight line that connects their centers together is the straight line OM. According to this rule number 9, the straight line OM must pass through point P, that is their touching point. Or in other words, OMP is one straight line. Again, OMP is one straight line. So we can implement this rule number 7. Here is rule number 7. If a line segment that is drawn from the center of a circle bisect a chord, then the line segment is perpendicular to the chord. So here, the center of this circle is at point O. From point O, we draw line segment OM that bisects chord AB. That is to say, AM equals to MB. So whenever a line segment that is drawn from the center of a circle bisects a chord, like in this case, OM bisects chord AB, then OM will not be only bisect the chord, but it will be also perpendicular to the chord. That is to say, if OM bisects chord AB, then OM also will be perpendicular to chord AB. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to this rule, rule number 7. We actually implement rule number 7 in our drawing. We join points O and N together by straight line. Line segment ON starts from point O, that is the center of the biggest circle. And line segment ON that starts from the center of the biggest circle bisects chord AC. Why? Because AN equals to NC. So according to rule number 7, whenever a line segment from the center of the circle bisect the chord, it will be also perpendicular to the chord. Because of the fact that ON bisect chord AC will be, because of the fact that ON bisect chord AC, ON will be also perpendicular to AC. So here ON is perpendicular to AC, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 7. Okay, so you can write down that ON is perpendicular to AC according to rule number 7. ON is perpendicular to AC. In addition, point Q is the center of this circle. Point N is the point on the circle itself. Therefore, QN is the radius of this circle that is equal to V units in its length. The radius QN is drawn to point N, that is the point of tendency of tangent AC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius NQ. If AC is perpendicular to NQ, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 1. So you can write down also that QN is also perpendicular to AC. The radius QN is perpendicular to tangent AC also. And from those two equations, ON is perpendicular to AC and QN is perpendicular to AC, we will derive that point O must lie on the radius QN. Okay? Point O must lie on the radius QN. Point O, that is the center of the biggest circle, lie on the radius QN. Well, because if point O doesn't lie on the radius QN, then ON will not be perpendicular to AC. Okay, in order that ON will be perpendicular to AC, it must lie on QN. Why? Because QN is also perpendicular to AC. So ON and point O must lie on QN. If point O lie on QN, it means that QON is one straight line. Okay, QON is one straight line. Line segment QON is one straight line. Now, all the 3 points Q, O, and N are located on the same straight line. At this point, this circle touches the biggest circle. We define the point of tendency of this circle with the biggest circle as U. We draw tangent VW, that is tangent to both circles at point U. This is tangent VW, that is tangent to both circles, to the biggest circle and to this circle at point U. Okay. So here, point Q is the center of the circle, point U is the center of the point Q is the center of this circle, point U is the point on this circle itself, therefore QU is the radius of this circle is equal to b units in its length. The radius QU is drawn to point U, that is the point of tendency obtained VW with this circle. Whenever you have a radius that is drawn to the point of tendency, then the tangent VW will be perpendicular to the radius UQ. VW is perpendicular to the radius UQ. So, that is to say, this angle equals to 90 degrees and this angle equals to 90 degrees. So I can write down that QU is perpendicular to tangent VW. The radius QU is perpendicular to tangent VW. In addition, point O is the center of the biggest circle. Point U is the point of the biggest circle itself. Therefore, OU is the radius of the biggest circle that we'll define as X. The radius OU is drawn to point U, that is the point of tendency of tangent VW with the biggest circle. Whenever you have a radius that is drawn to the point of tendency, then tangent VW will be perpendicular to the radius UO. If VW is perpendicular to VO, or if VW is perpendicular to UO, it means that this angle equals 90 degrees and this angle equals 90 degrees. So I can write down that OU is also perpendicular to VW. The radius OU is perpendicular to tangent VW also. So I found out that Q is perpendicular to VW and OU is also perpendicular to VW. And you can derive from those two statements that OQU is one straight line. OQU is one straight line. Well, because it means that all the 3 points O, Q and U are located on the same straight line. If, for example, point Q is not located on OU, then QU will not be perpendicular to VW. Why? Because if OU is perpendicular to VW at point U, then if point U is here, then UW, then QU will not be perpendicular to VW. In order that both OU will be perpendicular to VW and QU will be also perpendicular to VW, thus all the 3 points O, Q and U must be located on the same straight line. Okay? So I found out that OQU is perpendicular, OQU is one straight line and QON is one straight line. And from those two statements we derive that NQU is one straight line. Okay, from the fact that OQU is one straight line and QON is one straight line, we derive that NQU is one straight line. Line segment NQU is one straight line. So if NQU is one straight line, it means that NU is also a straight line. NU is a straight line. NU is a straight line. but NU is a straight line that touches this circle at point N and U. Therefore, NU is a chord that passes for point Q that is the center of the circle. Any chord that passes for the center of the circle must be the diameter of the circle. Therefore, NU is the diameter of the circle. NU is the diameter of the circle. But we also know that the diameter of any circle is twice as long as the radius, and the radius of this circle is b. Therefore, the diameter NU must be equal to 2b. Repeat again. NU equals to 2b. Okay. This is the diameter NU that is equal to 2b. One straight line. Okay, so the next step, we join points O and P together by a straight line. Point O is the center of the biggest circle. Point P is the center of the smallest circle. This smallest circle. The smallest circle touches the biggest circle at this point, and we find the point of tendency or the touching point as S. So I can say that the smallest circle have an internal notch with the biggest circle at point S, that is to say, it touches the biggest circle internally at point S. And here we have rule number 9. We implement this point, rule number 9. According to rule number 9, if two circles touch each other internally, then the straight line that connects their centers together passes for their touching point. The center of the big circle is at point O, the center of the small circle at point M, and the straight line that connects the centers together is OM. The straight line OM, according to rule number 9, must pass for point P. That is to say, OMP is one straight line. According to rule number 9, OMP is one straight line. You can implement rule number 9 in our drawing. Again, the smallest circle touches the biggest circle at point S. The center of the biggest circle is here at point O, the center of the small circle is at point P. The straight line that connects their centers together is the straight line OP. According to rule number 9, the straight line OP must pass for point S, that is to say, OPS is one straight line. OPS is one straight line. OPS is one straight line. So if OPS is one straight line, it means that OS minus SP equals to PO. Again, OS minus SP equals to PO. Alright, I write it down. OS minus SP equals to PO. Okay. OS minus SP equals to PO. What is the definition of the straight? Here, if OPS is one straight line, then OS must be also one straight line, of course. Then OS is also a straight line. So what is the definition of the straight line OS? The straight line OS starts from point O, that is the center of the biggest circle, and ends at point S, that is the point of the biggest circle itself. This is exactly the definition of a radius. Therefore, OS is the radius of the biggest circle that is equal to x, so substitute OS by x. Minus SP. We already found out that SP is the radius of this circle that is equal to 2, therefore we substitute SP by 2. So in conclusion, we found out that PO equals to x minus 2. Okay? PO, this line segment PO equals to x minus 2 units, and it's none. In the next step, we'll extend the perpendicular ON by a straight line. We extended the perpendicular ON, that is a straight line by a straight line, and the result is a straight line. OT is a straight line also. Why? Because when you extend the straight line by a straight line, the result OT must be also a straight line. So, and if you focus on this side of the straight line OT at point N, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at this side of the straight line OT at point N? We have this angle that is equal to 90 degrees plus the missing angle. In total, the must be equal to 180 degrees, therefore the missing angle must be also equal to 90 degrees. Okay. It is given us the equation that AC is tangent to the smallest circle at point M. Point M is the point of tendency. We join points P and M together by a straight line. Point B is the center of the smallest circle. Point M is the point on the smallest circle itself. Therefore, PM is the radius of the smallest circle that is equal to 2. The radius PM is drawn to point M, that is the point of tendency of tangent AC, the smallest circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius MP. If AC is perpendicular to MP, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. In the next step, we draw perpendicular on the radius MP at point P. Again, we draw perpendicular on the radius MP at point P. So this angle equals to 90 degrees according to our construction. And we will extend the perpendicular until it touches the extended ON. We define the touching point as point T. So actually, at quadrangle P, M, and T, we have 1, 2, 3 right angles. Therefore, the fourth angle must be equal to 90 degrees according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. So inside quadrangle P, M, and T, we have 4 right angles. Any quadrangle that has 4 right angles must be this rectangle if not a square. So we will relate to quadrangle P, M, and T as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, in rectangle PM and T, PM must be equal to NT, but PM is 2, therefore NT must be also equal to 2. Likewise, in rectangle MNTP, MN must be equal to PT. But MN is 7 over 2, therefore PT must be also equal to 7 over 2. Here we define line segment NO as H. In the next step, we'll implement the Pythagoras theorem on the right green triangle OPT, PTO. So I copy the right triangle OPT in a new page and implement on it the Pythagoras theorem. So actually, this is the right triangle OPT that I copied from the original drawing. We have already found out that the hypotenuse PO equals to x minus 2. We just right now found out that PT equals to 7 over 2. The perpendicular PT equals to 7 over 2. What is the length of side OT? On drawing, it's very easy to see that OT equals to Tn plus NO. That is to say OT equals to Tn, that is 2, plus NO, that is 8. In total, TO equals to 2 plus H. TO equals to 2 plus H. According to the Pythagoras theorem, in the right triangle OPT, PO square equals to OT square plus PT square. PO is x minus 2, therefore PO square is x minus 2 square. And it is equals to OT square. OT is 2 plus H, therefore OT square is 2 plus H square. Plus PT square. PT is 7 over 2, therefore PT square is 7 over 2 square. And open the brackets on both sides of this equation. And we get that x minus 2 square equals to x square plus 2 square, that is 4 minus 4x. And it is equals to 2 plus h square. 2 plus h square equals to 2 square, that is 4 plus h square plus 4h plus 7 over 2 square. 7 over 2 square equals to 49 over 4. In the next step, we join points O and C together by a straight line. What is the definition of the straight line OC? The straight line OC starts from point O, that is the center of the biggest circle, ends at point C, that is the point on the biggest circle itself. This is exactly the definition of a radius. Therefore, OC is the radius of the biggest circle, that is equal to x. We have already found out that, according to our definition, line segment NO equals to H. And we already found out that NC in the beginning of the lecture, and NC is equal to 13 over 2. It is after hypotenuse AC that is equal to 13. So NC equals to 13 over 2. So I copy the right triangle ONC in new page and we implement on this right triangle the Pythagoras theorem. So actually this is triangle, or the right triangle ONC that I copied from the original drawing. OC, hypotenuse OC is the radius of the biggest circle that is equal to x. ON equals to h according to our definition. And C equals to 13 over 2, that is what we already found out in the beginning of the lecture. So we implement the Pythagoras theorem on this right triangle ONC according to the Pythagoras theorem. OC squared, the right triangle ONC, OC squared equals to ON squared plus NC squared. Okay, so OC is x, therefore OC squared is x squared. That is equal to ON squared. ON is h, therefore ON squared is h squared. Plus NC squared. NC is 13 over 2, therefore NC squared is 13 over 2 squared, that is 169 over 4. In total, we found out that x squared equals to h squared plus 169 over 4. So we can substitute x squared here in this equation by h squared plus 169 over 4. We'll do it now and we'll get that again x squared is h squared plus 169 over 4 plus 4 minus 4x, that is equals to 4 plus h squared plus 4h plus 49 over 4. Okay. So here we have h squared on both sides of the equation, so h squared will get cancelled. We have 4 on both sides of the equation, 4 also will get cancelled. And we left only if 169 over 4 minus 4x is equal to 4h plus 49 over 4. We subtract 49 over 4 from this equation and we get that 169 minus 49 over 4 minus 4x equals to 4h. Here we'll add 4x to this equation and we get that 169 minus 49 it is 120, so in total this expression equals to 120 over 4, that is equals to 4x plus 4h. Here we take 4 as a common factor for those two expressions, and inside the brackets we will have x plus h. 120 over 4 is 30, so 30 equals to 4 times x plus h. Here we divide this equation by 2 and get that 30 over 2 is 15, so 15 equals to 4 over 2 is 2. 2 times x plus h. Here we divide this equation by 2 and finally we get that x plus h equals to 15 over 2. X plus h equals to 15 over 2. What is the length of UN? UN equals to UO plus ON. Again, UN equals to UO plus ON. That is to say, UN equals to UO, that is X, it is the radius of the biggest circle, plus ON, that is H. So in total, UN equals to X plus H. UN equals to X plus H. That is from one side. And from the other side, we have already found out that UN is the diameter of this circle that is equal to 2b. Here. We have already found out that NU or UN is the same, it is equals to 2b. You can find out that UN is also equals to 2b. UN, it is the diameter of the circle that is equal to 2b. 2 times the radius, 2b. And from those two equations, UN equals to X plus H and UN equals to 2b, we derive that X plus H equals to 2b. X plus H equals to 2b. We have already found out that X plus H is also equals to 15 over 2, so you can write down that X plus H equals to 15 over 2. And for this equation, 15 over 2 equals to X plus H equals to 2b, we will derive that 15 over 2 equals to 2b. 15 over 2 equals to 2b. We divide this equation by 2 and finally we get that b equals to 15 over 2 over 2. 15 over 2 over 2 is 15 over 4. So actually found out that the radius of this circle B it is equal to 15 over 4 units. And we have already found out that the radius of this circle A is 2. You can write down here that A equals to 2. So what is the ratio B over A? The ratio B over A is B that is 15 over 4 over A that is 2. 15 over 4 over 2 is 15 over 8. In terms of numbers, it is equal to 1.875. Repeat again, B over A, it is equal to either 15 over 8, or in terms of numbers, it is equal to 1.875. It is a ratio, it is without units. Okay. In the next step, I will summarize the lecture. In this lecture, we found out the ratio between two radii. The ratio between the radius of this circle that is B and the radius of this circle that is A, or the ratio B over A. So, in the drawing, we have a bigger circle. Inside this bigger circle we have two smaller circles. Again, the radius of this circle is B and the radius of this circle is A. In addition, we have the right triangle ABC that is partially located in the bigger circle. We know that side AB of the right triangle ABC equals to 5 units. The perpendicular BC of the right triangle ABC equals to 12 units in its length. And we also know that AN equals to NC. Again, our mission is to find out the ratio of B over A. In order to find out the ratio of B over A, we implemented the Pythagoras theorem on the right triangle ABC. According to the Pythagoras theorem in the right triangle ABC, AC squared equals to AB squared plus BC squared. Repeat again. AC squared equals to AC squared plus BC squared. So AC squared equals to AB squared. AB is 5, therefore AB squared is 5 squared, that is 25. Plus BC squared. BC is 12, therefore BC squared is 12 squared, that is 144. So in total, AC squared equals to 25 plus 144, that is 169. AC squared equals to 169. We took out all of this equation. If I know that AC equals to the square root of 169, that is 13. So the hypotenuse AC here equals to 13 units. At point N, the hypotenuse AC is bisected into two halves. The first half is AN and the second half is NC. That is to say AC over 2, that is 13 over 2. So half the hypotenuse is AN, and the second half is NC. Both are equal to each other. That is to say, we found out that AN equals to NC equals to 13 over 2. Each half equals to 13 over 2. Then I presented to you rule number 8, and we implemented rule number 8 in our drawing. According but before that, here we are. Here, AN equals to 13 over 2 and NC also equals to 13 over 2. Then according to rule number 8, the radius of a circle that is bisected, the radius of a circle that is blocked by a right triangle is equal to R equals to A plus B minus C over 2. So we have here right triangle ABC, and the ABC equals to 90 degrees. This right triangle ABC blocks the circle. The radius of this circle is R. The length of side AB is A. Side BC equals to B units in length. Side AC equals to C units in length. According to rule number 8, we can calculate the radius of this circle that is blocked by the right triangle ABC only by knowing the side length of the right triangle that blocks it. That is to say, the radius of this circle that is blocked by the right triangle R will be equal to A plus B minus C over 2. Again, R equals to A plus B minus C over 2. You can implement rule number 8 in our drawing. In our drawing we have the right triangle ABC that blocks this circle. The radius of this circle is A, so we can find out the value of A only by knowing the side length of the right triangle that blocks it. That is to say, A will be equal to, the radius A will be equal to AB plus BC minus AC over 2. Again, the radius A will be equal to AB plus BC minus AC over 2. Repeat again, for number 8, the radius A will be equal to AB plus BC minus AC over 2. AB equals to 5, BC equals to 12, and we just right now found out that the hypotenuse AC equals to 13, all divided by 2. 5 plus 12 is 17, 17 minus 13 is 4, and 4 over 2 is 2. So finally we found out that the radius A equals to 2 units in its length. The radius of the smallest circle A equals to 2 units in its length. Okay. Then we defined the center of the smallest circle, this circle is P. We define the center of this circle as Q here, and we define the center of the biggest circle as O. AB is tangent to this circle at point T. We join points C and P together by a straight line. Point P is the center of this smallest circle. Point T is the point on the circle itself, so for PT is the radius of this circle that is equal to A, that is equal to 2. The radius PT is drawn to point T, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius TP. If AB is perpendicular to TP, it means that this angle equals to 90 degrees, and this angle equals to 90 degrees. Likewise, we define the point of tendency of tangent BC if this circle is N. We join points T and N together by a straight line. Tn is the radius of this circle that is equal to 2. The radius Tn is drawn to point N, that is the point of tendency of tangent BC with this circle. And therefore tangent BC will be perpendicular to the radius NP. If BC is perpendicular to NP, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. So inside quadrilateral PTBN, we have 1, 2, 3 right angles. The sum of 3 right angles is 90 times 3 is 470 degrees. Plus the size of the fourth angle, in total must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. So inside quadrilateral PTBN, we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrilateral PTBN as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, Pn equals to Tb, but Pn is 2, therefore Tb must be also equal to 2. Likewise, in rectangle TPBN, Tp must be equal to Bn, but Tp is 2, therefore Bn must be also equal to 2. So after we found out that quadrilateral TPBN is not a rectangle but a square. Why? Because all of its sides are equal to each other, they are equal to 2. So here TB equals to 2, AB equals to 5, AB minus TB equals to 80. Again, AB minus TB equals to 80. So AB is 5, TB is 2, so 5 minus 2 is 3. So 80 equals to 3. Then we have rule number 2, that the lengths of two tangents from common external point to a circle are equal. We have the common external point, point A. From the common external point, point A, we have two tangents to the circle, tangent AT and tangent AM. And according to rule number 2, they are equal to each other. That is to say, AT equals to AM, but AM is 3, therefore AT is 3, therefore AM must be also equal to 3. We already found out that AN equals to 13 over 2. and AM equals to 3. Therefore, AN also here must be equal to MN. Again, AN also here equals to MN. Repeat again. AN also here equals to MN. AN is 13 over 2, AM is 3. 13 over 2 on 3. We multiplied minus 3 by 2 and then we divided by 2 in order to have a common factor with 13 over 2. So here we have 13 over 2 and minus 3 times 2 is minus 6. So we have 13 minus 6, that is 7, so in total this expression equals to 7 over 2. That is to say MN equals to 7 over 2. This time segment MN equals to 7 over 2 units in its name. In the next step, I presented to you for number 7 and implemented for number 7 in our drawing. Again, you should remember that point O is the center of the biggest circle. Only to rule number 7. If a line segment that is drawn from the center of a circle bisected a chord, then the line segment is perpendicular to the chord. Point O is the center of this circle. From the center of this circle, that is to say from point O, we draw line segment OM. And we know that line segment OM bisects chord AB. That is to say AM equals to MB. And whenever you have a line segment that is drawn from the center of the circle that bisects a chord, it will be also perpendicular to the chord. And because of the fact that OM bisects chord AB, OM will be also perpendicular to AB. That is to say this angle equals to 90 degrees and this angle equals to 90 degrees according to this rule number 7. We can implement rule number 7 in our drawing. Why? Because in our drawing we join points O and then together by side line. Point O is the center of the bigger circle. Line segment ON that is drawn from the center of the bigger circle, that is from point O, bisects chord AC. That is to say, divide this into two halves. AN equals to NC. And because of the fact that ON bisects chord AC, ON will be also perpendicular to AC. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 7. So you can write down that ON is perpendicular to AC. ON is perpendicular to AC. Then point Q is the center of this circle. Point N is the point on the circle itself. Therefore Qn is the radius of this circle that is equal to mu units in its length. The radius Qn is drawn to point N, that is the point of tendency of tangent AC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius NQ. If AC is perpendicular to NQ, it means that this angle equals to 90 degrees and this angle equals also to 90 degrees. So you can write down that Qn, the radius Qn is also perpendicular to tangent AC. And Qn is perpendicular to tangent AC. And for those two equations that ON is perpendicular to AC and Qn is also perpendicular to AC, we will derive that point O lie on Qn. Point O, that is the center of the biggest circle, lie on the radius Qn. Okay? If point O doesn't lie on Qn, then either ON will not be perpendicular to AC. Why? Because at point N, the radius Qn is perpendicular to AC. So if point O is here, and we know that QN is perpendicular to AC, then ON will not be perpendicular to AC. Therefore, point O must lie on the radius QN. Read again. Point O lie on QN. If point O lies on the radius QN, it means that QON is one straight line, okay? All the 3 points Q, O, and N are in the same straight line. Therefore, QON is one straight line. So again, QON is one straight line. This last segment, QON is one straight line. At this point, this circle touches the biggest circle. Define the touching point between the two circles as U, and then we draw tangent with W that is tangent to both circles at point U. So here we have point Q is the center of the circle, point U is the point of the circle itself, so for Q, U is the radius of this circle that is drawn to point U. That is the point of tendency of tangent VW of this circle, and therefore VW, tangent VW will be perpendicular to UQ. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees. So we can write down that QU is perpendicular to VW. QU is perpendicular to VW. Likewise, point O is the center of the biggest circle. Point U is the point of the biggest circle itself. This is exactly the definition of a radius. That is to say, OU is the radius of the biggest circle that is drawn to point U, that is the point of tangency of tangent VW of the biggest circle. And therefore, tangent VW will be perpendicular to the radius UO. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees. So we can write also that OU is also perpendicular to VW. Here, OU is perpendicular to VW. And from those two equations, QU is perpendicular to VW and OU is perpendicular to VW, we derive that OQU is one straight line. OQU is one straight line, or all the 3 points OQ and U are located on the same straight line. OQU is one straight line. Otherwise, if point O doesn't lie on the straight line QU, then OU, and we know that QU is perpendicular to VW at point U, then if point O is located here, and we know that QU is perpendicular to VW, then OU will not be perpendicular to VW. Because at point U, QU is perpendicular to VW. And if point O is located here, then OU will not be perpendicular to VW. So all the 3 points O, Q, and U must be located on the same straight line. Or in other words, OQU is one straight line. So OQU is one straight line. We already found out that QON is also one straight line. And from those two statements, we will derive that NQU is one straight line. NQU is one straight line. If NQU is one straight line, it means that NU is also a straight line. NU is a straight line, but NU is a straight line that touches the circle at points N and U. Therefore, NU is a chord that passes through point Q. And we know that any chord that passes through the center of the circle, that is to say, point Q, must be the diameter of the circle, therefore NU is the diameter of the circle. NU is the diameter of the circle. But we also know that the diameter of any circle is twice as long as the radius, and the radius of this circle is B, therefore the diameter NU must be equal to 2B. NU equals to 2B. Okay? This is the diameter NU that is equal to 2B. Then I presented to you rule number 9, and we implemented rule number 9 in our drawing. According to rule number 9, if two circles touch each other internally, then the straight line that connects their centers together passes through their touching point. Here, the center of the big circle is here at point O, the center of this small circle is here at point M. The straight line that connects their centers together is OM, straight line OM. This straight line OM, according to this rule number 9, must pass through point P. OM must pass through point P, that is to say, OMP is one straight line. Again, OMP is one straight line. Okay, so we can implement rule number 9 in our drawing. Our drawing, the biggest circle touches the smallest circle here at point S. That is to say, they have an internal between them, point S, this point, and the center of the biggest circle is point O, the center of the smallest circle is at point P. The straight line that connects their centers together is OP. The straight line OP, according to rule number 9, must pass through point S, that is their touching point. OPS is one straight line. OPS is one straight line according to rule number 9. OPS is one straight line according to rule number 9. So if OPS is one straight line, it means that SO minus SP is PO. Again, SO minus SP is PO. SO minus SP is PO. SO, should remember that SPO is one straight line. If SPO is a straight line, it means that SO is also a straight line. What is the definition of the straight line SO? The straight line SO starts from point O, that is the center of the biggest circle, and ends at point S, that is the point of the biggest circle itself. This is exactly the definition of a radius. Therefore, SO is the radius of the biggest circle that is equal to X, so I can substitute SO by X minus SP. SP is 2, so substitute SP by 2, so in total we found out that PO equals to X minus 2. This line segment PO, this line segment PO equals to X minus 2. Then we extended the perpendicular ON until point C. ON is a perpendicular, it is absolutely straight line. We extended the straight line ON by straight line. The result OT must be a straight line. If we focus on this side of the straight line OT at point N, the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles from one side of the straight line is equal to 180 degrees. So which angles we have at this side of OT at point N? We have this angle that is equal to 90 degrees plus the missing angle. In total they must be equal to 180 degrees. Therefore the missing angle must be equal to 90 degrees. This angle must be equal to 90 degrees. We know that CA is tangent to this angle at point M. Point M is the point of tendency. We join points P and M together by straight line. Point P is the center of the smallest circle, point M is the point of the smallest circle itself. Therefore PM is the radius of the circle that is equal to 2. The radius PM is drawn to point M, that is the point of tendency of tangent AC with the circle. And whenever I have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius MP. That is to say, this angle equals 90 degrees and this angle equals 90 degrees. Then we draw perpendicular on the radius MP at point P. Again, we draw perpendicular on the radius MP at point P. So this again equals to 90 degrees according to our construction. So in quadrilateral MNTP, we have 1, 2, 3 right angles. Therefore, the fourth angle must be equal to 90 degrees. According to the rule, that the sum of the angles in any quadrilateral is equal to 360 degrees. Then I copied the right angle OTP and we implemented the Pythagoras theorem on the right angle OTP. PO is x minus 2, PT is 7 over 2, and TO is Tn plus NO. That is to say, TO is Tn, that is 2, plus NO, that is h according to our definition. So this is the right angle POT that I copied from the original drawing. According to the Pythagoras theorem, PO square equals to PT square plus OT square. PO is x minus 2, therefore PO square is x minus 2 square. This is equal to OT square. OT is 2 plus h, therefore OT square is 2 plus h square plus PT square. PT is 7 over 2, therefore PT square is 7 over 2 square. We open the brackets on both sides of the equation and found out that x minus 2 square equals to x square plus 2 square, that is 4, minus 4x. This is equals to 2 plus h square is 2 square, that is 4 plus h square plus 4h plus 7 over 2 square is 49 over 4. Then we joined points O and C together by straight line. Point O is the center of the biggest circle, point C is the point of the biggest circle itself, therefore OC is the radius of the biggest circle, that is equal to x. ON equals to h and NC equals to 13 over 2. So actually, this is the right angle NC that I copied from the original drawing. According to the Pythagoras theorem, OC square equals to ON square plus NC square. OC is x, therefore OC square is x square, plus it is equal to ON square. ON is h, therefore ON square is h square, plus NC square. NC is 13 over 2, therefore NC square is 13 over 2 square, that is 169 over 4. So in total we found out that x square equals to h square plus 169 over 4. The next step is we substituted x square in this equation here by 169 over 4 plus h square. So here x square equals to h square plus 169 over 4 plus 4 minus 4x is equal to 4 plus h square plus 4h plus 49 over 9. We have h square on both sides of the equation, so h square will get cancelled. We have 4 on both sides of the equation, so 4 also will get cancelled. We left only with 169 over 4 minus 4x is equal to 4h plus 49 over 4. Then we subtracted 49 over 4 from this equation and found out that 169 minus 49 over 4 minus 4x equals to 4h. We added 4x to this equation and found out that 169 minus 49 is 120, so in total this expression equals to 120 over 4 and it is equal to 4x plus 4h. Then we took 4 as a common factor from those two expressions, so inside the brackets we have x plus h. 120 over 4 is 30, so in total we found out that 30 equals to 4 times x plus h. We divided this equation by 2 and found out that 30 over 2 is 15, so 15 equals to 4 over 2 is 2, so 15 equals to 2 times x plus h. We divided this equation by 2 and found out that x plus h equals to 15 over 2. Here, x plus h equals to 15 over 2. But what is the length of UN? UN equals to UO plus ON. That is to say, UN equals to UO, that is x, plus ON, that is h. So in total, UN equals to x plus h. So UN equals to x plus h. But we have already found out that UN equals to 2b. Here, UN equals to 2b. UN equals to 2b. So you can write here that also UN equals to 2b. And from those two equations, UN equals to x plus h and UN equals to 2b, we will derive that x plus h equals to 2b, but x plus h equals also to 15 plus 2. So you can write here that x plus h equals to 15 over 2. And from this equation, 15 over 2 equals to x plus h equals to 2b, we will derive that 15 over 2 equals to 2b. We divided this equation by 2 and found out that b equals to 15 over 2 over 2, that is 15 over 4, so b equals to 15 over 4. The radius of this circle B is equal to 15 over 4 units, it means 9. And we already found out that the radius of this circle A equals to 2. So B equals to 15 over 2, A equals to 2. And B over A will be equal to B, that is 15 over 4, over A, that is 2. 15 over 4 over 2 is 15 over 8. So in conclusion, we found out that B over A equals to either 15 over 8, in terms of numbers, it is equals to 1.875 units. Okay? Again. The ratio between the radius of this circle, that is B, over the radius of this circle, that is A, B over A equals to either 15 over 8, or in terms of numbers, it is equals to 1.875 units. Okay, thank you very much.